We live in a universe of many unexplained phenomena, and one of the most fascinating, at least in my opinion, is the phenomena of hypervelocity stars. Stars that travel so fast through our Milky Way galaxy that they will escape the gravitational influence of the galaxy and head out into intergalactic space towards an unknown destination. And there's a surprising number of these stars that we have detected over the years, including recent discoveries which seem a bit unusual, a bit difficult to explain. You see, astronomers have grappled with the problem of what force in the universe would possibly be powerful enough to propel an entire star, especially a larger star, to these kinds of velocities, especially a star like HE 0437-5439, which has traveled more than 250,000 light years beyond our galaxy at a speed of over 2.6 million kilometers per hour. What could possibly propel a star to these kinds of velocities? Well, the only force that astronomers can come up with is supermassive black holes at the center of larger galaxies such as ours. The supermassive black hole at the center of our galaxy definitely has the gravitational influence to propel a star at these kinds of velocities, assuming that they were in a binary pair, where one star is dragged into its doom at the center of the black hole, and the other part of the pair is flung out of the galaxy. However, there are other hypervelocity stars in the Milky Way, actually nearly half of the hypervelocity stars that we have detected thus far, that do not appear to originate from the galactic core. The supermassive black hole at the center of the Milky Way doesn't seem to have had anything to do with these stars. So what possibly could be propelling them at these kinds of velocities? Well, the astronomical community has some theories about all of this, theories that have yet to be substantiated, but they have studiously avoided an artificial explanation. The possibility that extremely advanced alien civilizations are actually responsible for this phenomena, transporting their entire solar system together with their entire civilization from one galaxy to the next, or perhaps from one part of the Milky Way to another. But the question remains, why would they invest the effort to do such a thing? And also, what kind of technology would it require to accomplish this sort of amazing feat? Well, interestingly enough, a recent discovery found at the heart of a galaxy not very different from ours might provide an explanation as to why an advanced alien civilization would want to get out of the Milky Way as rapidly as possible before this phenomena rips the galaxy apart and destroys all life in it. Good morning, alien enthusiasts, and welcome to the final day of Alien Week. Well, not quite the final day, because tomorrow we've got something really special planned for you in conjunction with the kickoff of Spaceflight Week, but we'll have one more piece of alien content tomorrow, for no other reason because I did that one piece of content about faked moon landings, which has nothing to do with aliens, so I'm doing that to kind of make up for that one day of lost content, at least for the UFO fans. Okay, all of that having been said, we're again addressing a topic that I've talked about a few times on this channel, and that is the concept of alien civilizations relocating their civilization by means of something called hypervelocity stars. Now, this is something that is highly controversial, to say the least, but when it comes right down to it, it's actually backed up by a fair amount of evidence. The current school of thought on the part of at least some astronomers is that the hypervelocity stars that we have detected within our galaxy, the ones that don't seem to originate from the core, where a supermassive black hole exists at the center of the Milky Way galaxy that has the gravitational strength to fling an entire solar system, or at least an entire star, up to the velocities that we've seen, there's a collection of stars that don't appear to have originated from there. So the current theory is that the remainder of these stars, or actually nearly 50% of them, depending on whose estimates you're looking at, come from another galaxy called the Large Magellanic Cloud, or the LMC. Now, to be clear, this is a black hole that has not been detected. This is the only evidence to suggest that there is a supermassive black hole at the center of the Lesser Magellanic Cloud, is the fact that these hypervelocity stars exist, and astronomers can't come up with any other reason, at least reasons that they're willing to entertain, that these stars might be traveling at this kind of velocities fast enough to escape the galaxy. And so, therefore, this appears to be maybe where all of these stars are coming from. But there's some very, very big holes in this theory. But of course, if there are holes in this theory, and these stars aren't coming from a supermassive black hole at the center of the Magellanic Cloud, and they're not coming from the center of the Milky Way either, then where are they coming from? And if hyper-advanced alien civilizations are responsible for these hyper-velocity stars, then why are they doing this? Why are they relocating these solar systems? And why would they be in such a hurry to escape the galaxy? Well, I've already talked about one major event that is going to be befalling our galaxy in the next few billion years. As a matter of fact, it's going to happen before our sun goes out, before our own end of days, our own apocalyptic end of the Earth event. Before any of that happens, something far more significant is going to be happening to the Milky Way galaxy, but it gets even worse. An anomaly that's been seen at the center of a galaxy not too unlike ours may indeed happen to ours as well. And if this anomaly were to occur within our galaxy, it would very possibly scour the entire Milky Way of all life. And I can't think of a better reason to get the hell out while you still have the opportunity. As I mentioned before, established thinking, backed up by a fair amount of existing evidence, says that hypervelocity stars originate in the galactic center. Astronomers think they come from binary star systems that got too close to what is called Sagittarius A, which is the Milky Way's supermassive black hole. And in this scenario that you're watching right now, one of the binary stars is captured by the black hole, and the other is ejected as a hypervelocity star. This is called the Hill's mechanism. Indeed, some of the original evidence supporting the existence of Sagittarius A was based on fast-moving stars in the galactic center by the Hill's mechanism. However, a large number of hypervelocity stars have also been discovered, and they were actually turned up in the early 2000s, that do not seem to be coming from Sagittarius A, but from another location. And new research submitted to the Astrophysical Journal just a few weeks ago shows that a surprising number of Milky Way's hypervelocity stars come not from the galactic center, but from what's called the Large Magellanic Cloud, which is a smaller galaxy that orbits the Milky Way. The paper is entitled, quote, "Hypervelocity Stars Trace a Supermassive Black Hole in the Large Magellanic Cloud." The lead author is Jiwon Han, a grad student at the Harvard and Smithsonian Center for Astrophysics who studies galactic archaeology. In 2006, researchers published the results of a survey of HVSs, or hypervelocity stars. We'll call them HVSs from here on out. And that survey detected 21 HVSs that were unbound B-type main sequence stars in the Milky Way's outer halo. Their properties were consistent with stars ejected from the galactic center by the Hill's mechanism, but as I said before, they were not coming from the Sagittarius A supermassive black hole, but from another source. Now, by making use of the Gaia Space Telescope, and by the way, you're watching an ESA video about that particular telescope and its discoveries, this team was able to find a lot more information suggesting that these stars had a point of origin in the Large Magellanic Cloud. Not only that, there's a whole region of space in the Milky Way galaxy that has too many stars compared to the surrounding area of space. It's in the Leo constellation, and it's called the Leo overdensity. And once again, according to this team, the data suggests that this supermassive black hole at the center of the Lesser Magellanic Cloud is chucking one star after another into this region of space, some of which are traveling at relatively moderate speeds, and the rest are traveling at hyper velocities. But as I mentioned earlier, there are problems with this theory. For one thing, we see no evidence of a black hole at the center of the Large Magellanic Cloud. Indeed, supermassive black holes are very, very unusual at the center of smaller galaxies. They just don't happen that often because you need a lot of stellar masses to build a supermassive black hole, even a relatively small one that has a mass of 600,000 solar masses, 600,000 times the mass of our sun, which isn't nearly as much as Sagittarius A, but still a colossal supermassive black hole at the center of a relatively small galaxy. And we've seen no evidence of Hawking's radiation or even stars that seem to be moving at a very high velocity around a central point where this supermassive black hole theoretically should reside. The only evidence that the team has for the existence of this black hole right now are these stars. But here's the problem, at least as far as the scientific community is concerned. There are no other explanations for the existence of these kinds of stars. There's nothing else in the universe that can propel a solar system to these kinds of velocities aside from a black hole with 600,000 solar masses. But even if that were true, even if there is a supermassive black hole lurking at the center of this galaxy that we just haven't seen yet, it doesn't explain these HVSs and just how many of them there are and their velocity. Approximately half, or at least 30% of the HVSs that we have detected thus far seem to be coming from this point in space. In other words, at least 1/3 and perhaps as much as half of all of the rapid velocity stars that exist in our galaxy are coming from this one supermassive black hole. A supermassive black hole that has a total mass of about 15% of the mass of Sagittarius A. How is this possible? How does such a small supermassive black hole chuck out this many stars on such a regular basis compared to the much larger supermassive black hole that dwells at the center of our much larger galaxy? And on top of that, let's assume that the reason this smaller supermassive black hole has chucked out so many stars is because the escape velocity of a smaller supermassive black hole is less than the escape velocity of Sagittarius A, substantially less, and so therefore a lot more of these stars can escape, and that would explain it. Well, that doesn't explain the velocity. If indeed it does require a much higher velocity to escape from Sagittarius A, that would mean that any HVSs that have escaped from Sagittarius A must be traveling at a higher velocity. They must have achieved this higher velocity in order to escape from this much bigger black hole in the first place. And also, this much more powerful black hole must have propelled these stars at a much higher velocity in the first place because of its massive gravitational energy. And yet, the HVSs that supposedly originate from the Large Magellanic Cloud are traveling no faster on average than the HVSs that came from the center of the galaxy. There doesn't seem to be any appreciable difference between the two sets of stars except their point of origin. And as if that weren't enough, there's another factor to be considered. You can't just determine the point of origin of an HVS or any star for that matter based solely on the theoretical strength, gravitational strength that is, of a supermassive black hole. You also have to take into account galactic motion, the motion of both the Large Magellanic Cloud and the Milky Way at the time of this supposed ejection. That would have a significant impact on the trajectory of the star and could throw all of these calculations off. And up to this point, the team has not studied the orbital mechanics of either galaxy to confirm their hypotheses. And yet, this hasn't stopped the media from announcing in one article after another that we have found a supermassive black hole lurking in a nearby galaxy. Nothing has stopped them from making these sorts of claims. And once again, the principle of extraordinary claims requiring extraordinary evidence only seems to apply to theories that the astronomical community or the scientific community in general doesn't like. If they like the hypothesis, then you don't need as much evidence. So what about the hypothesis that I put forward on a regular basis on this channel? The idea that at least some of these HVSs are actually being propelled by artificial means. Well, the evidence would seem to support this notion as well. Stars coming from a roughly similar area of space, in other words, perhaps an interstellar civilization sending the various stars that comprise their civilization on a massive journey propelled by extremely advanced and ambitious stellar engines. The one you're looking at right now is called the Svornos Star Tug, which is sort of a modified Kaplan thruster. What this does is it utilizes concentrated stellar energy to stimulate the outer surface of a star and create beams of solar wind, which are subsequently collected by a Bussard ramjet assembly. And then once the ramjet collects all of this solar wind, it forms a new element called oxygen-14. And powerful jets of this oxygen-14 can be used to push the star, whereas it can also produce directed plasma back towards the star to stabilize the orbit of the engine. Now, this engine, in theory, would use a 10 to the 12th power kilograms, or a trillion kilograms of solar material per second in order to produce a maximum acceleration of 10 to the negative 9th power meters per second squared. A tiny amount of acceleration, but keep in mind you're accelerating an entire solar system here, which would yield a velocity of 200 kilometers per second after 5 million years and a distance of 10 parsecs over a period of 1 million years. And theoretically, this engine could work for 100 million years given the mass of the star. But the star could achieve galactic escape velocity long before that, 200 kilometers per second after 5 million years, meaning that after about another 5 million years, the star would be traveling at roughly the same velocity as many of the HVSs that we have detected up to this point. Now again, this may seem like a painfully slow method to travel between the stars or between galaxies. It would take many millions of years, but if we're talking about a hyper-advanced civilization with perhaps technically immortal beings, then perhaps that kind of transit time wouldn't be so daunting to them. And again, all of this seems to fit. A group of stars all coming from the same region of space and all heading towards the same destination. But couldn't we detect an engine like this, an alien megastructure literally pushing stars across the galaxy? Well, yes, if we were looking for them, but up to this point, astronomers are so close-minded about the concept that they haven't put any significant energy into finding a megastructure orbiting one of these stars. All right, so we've addressed hypervelocity stars. We've addressed where astronomers think they're coming from and why they're traveling at the velocities that they travel at. But we've also seen the major holes in these theories, and we've addressed the ways that alien civilizations might be moving their solar systems instead. But, of course, the question still remains, why do it? What kind of cataclysm would be so frightening that an alien civilization would choose to relocate their entire civilization billions of years ahead of time? According to the Royal Astronomical Society, a terrifying glimpse at one potential fate of our Milky Way galaxy has come to light thanks to the discovery of a cosmic anomaly that challenges our understanding of the universe. An international team of astronomers led by Christ University, Bangalore, found that a massive spiral galaxy almost 1 billion light years away from Earth harbors a supermassive black hole billions of times the Sun's mass, which is powering colossal radio jets stretching 6 million light years across. That is one of the largest known for any spiral galaxy and upends conventional wisdom of galaxy evolution because such powerful jets are almost exclusively found in elliptical galaxies, not spirals. It also means the Milky Way could potentially create similar energetic jets in the future with the cosmic rays, gamma rays, and X-rays they produce wreaking havoc in our solar system because of increased radiation and the potential to cause a mass extinction. Quote, "This discovery is more than just an oddity. It forces us to rethink how galaxies evolve and how supermassive black holes grow in them and shape their environments," according to lead author Professor Joydeep Bakshi of Christ University. If a spiral galaxy can not only survive but thrive under such extreme conditions, what does this mean for the future of galaxies like our own Milky Way? Could our galaxy one day experience similar high-energy phenomena that will have serious consequences for the survival of precious life in it? In the new study, which has been published in the monthly notices of the Royal Astronomical Society, researchers unraveled the structure and evolution of the spiral galaxy 2MASX J23453268-0449256. You need to get used to all of this craziness if you're talking about astronomical phenomena. And by the way, this galaxy is 3 times the size of the Milky Way. Utilizing observations from the Hubble Space Telescope, together with analyses from several others, they detected an enormous supermassive black hole at its heart and radio jets that are among the largest known for any spiral galaxy, making it a rare phenomenon. Traditionally, scientists believe that the violent activity of such colossal jets of supermassive black holes would destroy the delicate structure of a spiral galaxy. Yet, against all odds, this galaxy has retained its tranquil nature with well-defined spiral arms, a luminous nuclear bar, and an undisturbed stellar ring, all while hosting one of the most extreme black holes ever observed in such a setting. Adding to the enigma, the galaxy is surrounded by a vast halo of hot X-ray emitting gas, providing key insights into its history. While this halo slowly cools over time, the black hole's jets act like a cosmic furnace, preventing new star formation despite the presence of abundant star-making material. Essentially, this black hole is destroying this galaxy even though it's maintaining its structure. It's preventing new stars from forming, meaning that it will suffer an early death. Now, our own Milky Way has a 4 million solar mass black hole, much smaller at its center, as I mentioned before, but this is currently in an extremely quiet and dormant state, fortunately for us. That could change if a gas cloud, star, or even a small dwarf galaxy were to be accreted by the black hole. Something else could change it too. We'll get to that in just a moment. This could potentially trigger significant jet activity. If large jets like this were to emerge from Sagittarius A, their impact would depend on their strength, direction, and energy output. But one pointed either at or near our solar system would strip away planetary atmospheres, damage DNA, and increase mutation rates because of radiation exposure. But that wouldn't matter terribly much to us because it would also strip away our ozone layer, leading to a mass extinction event on our planet. Not only that, high levels of radiation can damage things like technology too. It would be incredibly dangerous to an artificial civilization, an AI civilization, as it would be for a biological civilization. But is something like this likely to happen to Sagittarius A? I mean, it is a much smaller black hole than the one that was recently discovered. Well, something is about to change that, something I've mentioned a number of times on this channel. A few billion years from now, before our sun actually expends its hydrogen fuel and goes out, leading to the destruction of Earth, our entire galaxy is likely to be destroyed as well by a collision between the Milky Way and the Andromeda galaxy. And even though stars are unlikely to strike each other during the formation of this new galaxy, which is going to be called Milkomeda, something else is very likely to merge, and that is the two supermassive black holes at the center of each respective galaxy. And the supermassive black hole at the center of Andromeda is substantially larger than the black hole at the center of our galaxy. And a cataclysmic merging of both of these supermassive black holes would create a much bigger, much more active, and much more radioactive monster in the place of our old, far less dangerous Sagittarius A. And a black hole like this is something that no one would want to be close to, especially when you consider the consequences that we have observed in this faraway galaxy. And granted, this is going to happen approximately 4 billion years from now, but still, that is very, very soon in terms of the overall age of the universe. And if we're talking about civilizations that are essentially immortal, well, this is something they might want to avoid at any cost. Pretty damn frightening. Now, of course, this is something that's not going to happen within our lifetimes, our children's lifetimes, 1,000 generations in the future. This is not something that is going to happen. But to an extraterrestrial civilization that measures their timeline in millions or perhaps even billions of years, civilizations that have achieved essential immortality, because keep in mind, it's very possible, and this is something Elon Musk has been working on for some time, that at some point we could transfer our consciousness into an artificial intelligence. I mean, this is technology we're working on right now. This might be the logical conclusion of virtually every alien civilization, that ultimately, in order to achieve immortality, they transfer their very essence, their thoughts, their minds, their souls, if you will, into an artificial intelligence and essentially live forever. But if you are going to live forever, then you need to be really, really cognizant of serious and dangerous things that may transpire in the distant future. And again, if these extremely advanced civilizations have a better idea of what is likely going to happen several billion years from now, if they can predict it through far more advanced mathematics than we have at our disposal, if they can predict these events billions of years before they happen, and if these are the sorts of events that would bring the downfall of their civilization, keep in mind, an artificial intelligence requires enormous amounts of power in order to be able to function. Hideous amounts of power. If we're talking artificial intelligence, this is made up of thousands, millions, billions, or perhaps even trillions of separate minds. If all of these minds have been transferred into the machine, so to speak, then the amount of power they would require would be exponentially greater. And a galaxy being ripped to shreds by a supermassive black hole with an attitude is not the kind of place you would want to be, whether you are an artificial or biological intelligence. Either one would want to get the hell out of Dodge. Thank you very much for watching. Please don't forget to like and subscribe. Once again, I am heading to Space Symposium, actually in Colorado right now, at my best friend's home. His military memorabilia behind me, actually, was always a huge collector of World War II and Soviet stuff. Amazing what this guy had in any event. Sadly, he passed away 10 years ago, but his wife became my best friend after that, and she puts me up here a lot of the time when I come to visit. Always very grateful for that. But going to Space Symposium on Monday, can't wait for all of that to happen. And I'm still running a bit in the red on all of that. And of course, I want to go to the National Archives to dig up their UFO information too. And some folks, generous folks on PayPal, have contributed over 50% of the money I need for that. I only need about $400 here. They've contributed more than half of that. If all of that is something you would like to contribute to, details in the description. Thanks again for watching, and until next time, stay angry. about space.